At the chair of Power Electronics at CAU, we are contributing to Kielflex by creating its lab demonstrator. Briefly, here is a microgrid setup which is connected to the electric vehicle charging point, and a feedback is taken for the proper operation. This setup is built up for the first quartile of Kielflex. Now let's take a closer look to the main components of the system. Here we have the real-time digital simulator which can emulate various scenarios, and for instance now it emulates the behavior of a grid system with multiple EV charging stations. This RTDS works with RS-CAD software. The RTDS is connected to a Spitzenberger power amplifier which stands here. So with the help of these two components, we can emulate the current and voltage of a real grid. Here is the core power electronics part which emulates the charging station, and within this we have two Danfoss FC302 voltage source converters, 4 kVA each, the DC link, the passive load, EMI filters, the controller, the communication part through which we will send and receive data to and from IFF Magdeburg, etc. Each of the two voltage source converters can be used as two isolated charging stations or as a single charging station. Therefore, the system is flexible for different scenarios. The converter emulates the charging station and acts as a grid following converter in the grid. We control the Danfoss FC302 converter with DSpace, which actually emulates the charging station. Then, in future, we have the possibility, or we may connect this microgrid setup with the electric vehicle charging point. At this stage, we can collect the data from this charging station and feed it back to the converter, which actually emulates the behavior of the charging station under the grid. Meanwhile, this collected data is communicated to Fraunhofer IFF Magdeburg, which will then send us back the real and reactive power set points. These real and reactive power set points will be implemented by CAU in the DSpace and the simulation to control the hardware and to provide grid services such as steady state or dynamic voltage control.